Okay, welcome people to this tutorial, which is dealing with a certain part of this tow bar assembly, specifically with this U-shaped bracket that we see here, which is welded to the underside of the tow bar. So if we first of all go back to the drawing that's given to us in the classwork, and we need to do some analysis of that drawing, so we'll just pop over to PowerPoint. And we can see here's the bracket made from MS, which stands for mild steel. And we can, from this drawing, analyze it and work out some dimensions and a way we can go about drawing it. So if we first of all look for its overall dimensions, it's a U shape. It's 52 millimeters in length. And if we look for a height here, we can see on the right hand side we've got some lines extending down to what would be a corner. But we can see there's rounds there as well. But the distance from that corner would be 25, and then distance from that center line to the end is 12.5. So an overall height of 37.5. Overall width is given to us here of 25. So I'd like to show you an alternate way to create this object rather than just sort of drawing it as a full U. So we just remember those dimensions, 52 by 37.5 by 25, and we'll start with that. So I'll pop over to Creo. As we normally do, create a new part. I'm going to call this one bracket 2. Click OK, of course. Click OK. Turn your planes on, wherever that might be, and choose one of the vertical planes to put your first sketch onto. Click onto the sketch button, of course, and we can start to sketch. Now what I like to do is to put one line down first, just any length. Finish it by clicking on the center mouse button or clicking on the select button. And then once you've done that, we can, oh, mouse again, funny, come back here, mouse. Once we've done that, we can then start to put some dimensions in. Oh, that did a crazy thing to me. My mouse got a bit crazy. I don't want that little line I just drew then, so I'll just get rid of that as well. Strange things are going on there. Anyway, it's said it's 136. I certainly don't want that. So what I'll do is I'll change that to 52, which represents the length of the actual bottom of the U. Then everything else we draw from there, lines are going to be relative to that 52 millimeter line. So I'm going to go back to my line tool again and snap to the end of this line, drag a line up vertically, the V for vertical, center mouse button to finish that, and come over to my right hand side of the baseline, drag a line up vertically, see the V constraint appears, and keep dragging it up until you see the L appears on both of those, which means that is a line of equal length. You can see the L on the right and the left there. And center mouse button to finish. Now, normally at this point, you would get out of here. You would then complete this by drawing this inside L shape, but I want inside U shape. But I want to show you an alternative today. So I'm just going to accept this sketch just as a series of lines, just to demonstrate something, and turn around 3D. We'll go to the extrude tool, as if we were going to extrude this, and then we can see that when we do hit the extrude tool, rather than it going to a default solid, it actually defaults to extruding it as a skin or as a surface. That's because it was an open loop of lines. Now we can actually use a thicken functionality here rather than doing it as a surface. So if you click onto the extrude as solid, this box becomes available, which is basically saying that sketch or those lines that you drew can be thickened by an amount. And I know that from my drawing, if we go back to PowerPoint, it tells me here that the thickness of this actual bar, here it is here, is 6 millimeters thick. So what I'll do is in my thickness here, I'll type in 6 and enter. And you can see that it now assigns a thickness to that line. Now it's important here to see that the red line from the sketch is on the outside, and it's assigned the thickness to go to the inside. You can scroll through some other options here. I just want to get that to roll around a bit. If I click on this icon here beside the thicken, we can change the direction that it thickens in. So I click once and you can see it goes, it's gone on the outside of the red line. Click one more time and it will should go to the mid of the red line. You can see it's gone 3 mil either side, and click again to scroll back and you can see it's gone to the inside of the red line, which is what we're after. And if we remember back to our drawing, the whole thickness was a distance of 25. And except that, that's just something that's a little bit different to the way we might have done things in the past. So the thicken functionality within extrude. Now at this point here, I might just turn these sketches off. Sorry, not sketches, the planes off, so I can see things a bit easier. And if we go back to our drawing, we'll look at the next thing to actually complete. I'd probably now go about doing these rounds that are on the inside and on the outside of this 6mm thick bar. Now there's nowhere on the drawing that actually gives you a radius, so I'm going to assume that these radiuses are equal to the thickness of the material, meaning that it's a gradual bend to equal thickness of the material. So they're going to have rounds of 6mm. If it's not given to you in a drawing, then it's implied by some other means, which in this case is the thickness of the material. So we'll go back to Creo and roll my object around slightly, use my left click button use my right click button I should say, until I get the object actually highlighting the piece that I want. It's a bit strange, this mouse. Okay, there's ones selected. Hold down the control key, hover over the next one you want, select, select, and select. Oops, select, there it is, I've got all those 4 selected. Now I've got them selected, I go up to my round tool and simply then type in the value of 6mm, hit the enter key, and you can see it's assigned a 6mm round to all those 4. I'm happy with that, tick the green tick, and that is that easily done. Okay, back to our drawing again. So the next easiest thing to do would be probably these chamfers on top. We can see that the 1, 2, 3, 4 edges of the top of that U shape there have been chamfered off, probably for the purposes of them being a bit safer so you don't cut your fingers on them. And they are a 4mm chamfer at 45 degrees. 4mm meaning from the outside edge to where it starts is 4mm. So we can do that with our chamfer tool. So once again we'll select that edge, hold down control, select the other edges. 1, 2, it's been painful to me. 2, 3. Okay, got them there. And where's the old chamfer tool? There it is there, chamfer. Now within chamfer you've got different ways of setting it, so we'll have a look at that. There's dimension by dimension, D1, D2, angle by dimension, and look at defaults to 45 by dimension. So I'm going to choose 45 by D, and then the dimension was 4mm, and hit the enter key. And you can see it now puts a 4mm chamfer. That's an angle of 45 degrees, and we're happy with that, so we'll tick that. Okay, next thing to do is most likely going to be these holes. So we can see we've got 2 holes in the bracket. This hole's got a label on it saying M10 by 1.5, whereas this hole has just got a diameter. So there's quite a distinct difference between the 2 of these. This one with just the diameter means it is literally just purely a hole, whereas this one here with the M10 is a giveaway that it's a hole with a thread. And if you look here, M10 by 1.5, another part of our objects for this tow bar is also the bolt, which has an M10 by 1.5 thread as well, which means of course that this thread must go into that thread there. So we're going to use the hole command, not just circle and extrude, to actually complete these 2 holes. So go back to Creo. I want you to choose a surface on the end of one of the U's, it doesn't matter which side it is, and we're going to put the simple hole in first of all on this end here. So come up to this engineering command here, click on hole, and you get a random circle, or if you like hole, appearing on that surface, and it wants us to give it some information. The first thing you do is these green handles here, you grab them and you lock them onto an edge like so. So you can see I've locked that onto that top edge. Another green handle here, I'm going to lock that onto this edge over here. My mouse has been shocking to me. There it is there. So I've locked it onto that vertical edge, locked onto the horizontal edge, and we would know if we look back at the drawing, it is equally placed, or the hole is halfway between the two outside surfaces. So I know that would be 25 divided by 2. So I can actually type in there 25/2 and enter, and that will do the calculation for you. Same with the top one here, 25/2, that was also 12.5. Ooh, that doesn't look right. Done something wrong there. Let me quickly go back and have a quick look. 12.5 to the center. That was right. Have I made an error with my 37? Let's have a good quick look back. Okay, so if I'm not sure about a distance here, what I'll do is I'll just accept that hole there for a second. And if I'm not quite sure whether I've got the height right for some reason, I can use within the tools, the analysis tool. So click on analysis, come to measure, click on this third icon in which allows me to measure distance, and I'm going to choose that top edge there, and perhaps this bottom edge here by holding down, do I hit control? I don't hold control down. And it's measured in a vertical distance, which isn't quite what I'm after. So what I might do is just look for two vertical distances, that one there, and scroll that around. No, that one's below it. Control, select. And we can see here that is only 26 millimeters for some reason. So I've made a mistake there. So what I'll need to do is go back and fix that. That's okay. Just get out of the measure tool once you've used it by clicking on the red cross there, or center mouse clicking. Go back to my initial sketch, edit definition. Oh, what the heck's that thing? I don't know what that is. Line style. Nothing to do with that. Go back to it again. Try it again. Right click, edit definition. There we go. No, for some reason I forgot to change that. Right, that was 37.5, I think, wasn't it? It was. And okay to that. There we go. That looks better. Yep. Alright, so back to our first hole again, edit definition, and okay, 12.5 down from the top, 12.5 in from the edge, and it's a standard hole. So look across the top here in the ribbon bar, create a simple hole, that's what we want. Its diameter is of 10, and that is just its depth that it goes in. I mean, if you want to be picky, you could tell it to, stop at a certain depth, I suppose, but there's nothing else in there. So that's okay. And just click OK for that one. So that's a really simple one. And all we need to do now is do a similar process to the other face on the other side here. But we just need to assign a different type of hole. So select that face, go to Model, go to Hole again, grab your green handles, lock it on the top there. Grab the green handle, lock it on the edge. Make sure these are also 12.5. 12.5. And this time, rather than just selecting a simple hole, the next icon over says a standard hole. Standard hole basically meaning it's going to have a thread, a hole with a thread in it. The next icon across talks about adding a tapping. Now, tapping is another name for thread. So we've got that highlighted. And as soon as you've highlighted that, then you can actually create a tapered hole, but we don't want a taper. And this next box over here defines the type of thread that we're going to put into it. So metric threads are built on, or another name for metric is ISO. So accept that ISO. And then the next box over gives us the option of choosing all the different types of metric threads that are commonly used. So this one it defaults to is M1 by 0.25. We're going to make something a lot larger than that. So I'm going to use a little scroll down here until I find my M10 by 1.5, I think it was. Just going to go back and check that. M10 by 1.5. So metric 10 by 1.5 being the pitch. And where were we? There it is here. M10 by 1.5. This is just the depth. We don't need to worry about it. We're not going to put a countersunk hole. We're not going to put a counter bore either. And we're simply going to accept that. Now you can see here that the hole size is actually less than 10.5, but the thread size is 10.5. So these two holes actually look like they are a different size, which is important because when we assemble it later, we'll need to know which one to put the threaded end into. Okay, so that's basically the bracket going in, and then the next lesson will be how to place that onto the tow bar itself. Okay, let's save that, and then we'll do the next one.